Hello everyone. So right now we have this in front of us, learning the C programming language by creating a vector. This is not structured in your traditional way that we firstly start with the basics of what the C programming language is, what the syntax is, how you declare variables, how you declare functions, loops, conditional statements and all. No, I haven't done things that way because I personally found it difficult to follow such courses that take these basic things at a much slower pace. There's nothing wrong with that, and it's actually helpful for many people. It's just something not for me. So, the way I like to do things is, I don't know if it's unorthodox or not, but before I even learn to walk, I like to run and run as far as I can go and then just trip over. And whenever I trip over, then I start to learn how to walk. And this course is again based upon that basic fundamental ideology there. And okay, so let's get started. So this is the outline. Firstly, we have the need for dynamic arrays here. This comes even before identifiers, types, pointers, or anything that is related to the C language. And this here is basically because our project revolves around creating vectors. Now, what is a vector, right? This is something that will be essential to understand before you can even continue with the course because, our end goal is to create a vector in C. And why in C only? Why not in something else? That's also something that we'll discuss further down the line. The next thing we have is memory in C, call stack, and heap. So if you're coming from a much more different background, like something like Python or Java, then I don't know if you might have heard of this term, but this is called a garbage collector. Garbage collector. So these two languages work on a garbage collector. Now, what is a garbage collector? A garbage collector is basically just a program that handles the memory on your computer for you so that you don't actually have to juggle around the memory manually and just fret over how many bytes to allocate here, how many bytes to free from somewhere else. No, the garbage collector handles everything for you. And this is one big reason these languages are high-level programming languages because you don't actually have to do anything related to the memory by yourself. The garbage collector does it. And the garbage collector is a pretty cool thing. Like it's a really nice piece of tool we have here, but it adds an overhead to these programming languages. And that's just that these are pretty slow. Like Python is notorious for being slow. Java is okay. Java works pretty fine. But if you compare it with something like C, C++, or Rust, you can clearly see that Java doesn't come close in any of these languages in terms of speed and performance. And that's basically because it has a garbage collector that's running in the background, handling the memory for you. Garbage collector adds a big overhead that can affect a language's speed and performance, and thus many well, not many, just most low-level languages have manual memory management. Rust is a bit of a unicorn here. Rust came up with a different kind of memory management technique that's called ownership and borrowing. That's a topic for another day. Right now, we are most interested in C. Now, C requires knowledge about what a call stack is and what a heap is. Now, these are topics that aren't exclusive to just C. These are available in any language basically. Even Python has a call stack, and underneath it also uses a heap to manage all these uh, data structures that we take for granted, like a list. You might know list because it's basically a data structure that can grow with size. Well, it can grow as you keep on adding elements to it. So a list can have a singular element, but if you add another, a list can just grow into something that's of length 2. If you add another element, let's say 3, then this just becomes 1, 2, 3, and so on and so forth till infinity. It can just grow as big as your computer allows you. So this is what's called a dynamic array. A list is a type of a dynamic array. We'll discuss this later on. But for this, just remember that these data structures that are available in something like Python, they too run on the same concepts of call stack and heap. Next up, we have identifier types. Now, identifier types are again something that are not exclusive to C. Identifiers are just available in any type of language. Types are also available in other languages like Java, TypeScript, then Rust, and so on and so forth. Any statically typed language has types built into it. Again, I'm just taking something like Python or JavaScript. These languages are not statically typed. These are dynamically typed languages. They just figure out what the type of any variable or just a constant is by themselves. These are statically typed languages, and C also falls into this category. C is again a statically typed language. That's why it again has types in it. Next up, we have pointers. Now, what are pointers? Pointers are pretty dangerous topic that many people, many students that I personally know are still scared of discussing, and they are pretty confused what a pointer is. But pointer is not that difficult of a topic. It's a singular line statement. A pointer is just a memory address. So a pointer is just a memory address. It is nothing more than this. The same way integers, strings, and many other things exist, a memory address exists. What is a memory address? Why is it needed? That we'll discuss later on. Next up, we have linked list and vectors. Linked lists and vectors are just a type of dynamic array, or just two types of dynamic arrays we have. Linked list is the first implementation, then we have vectors. Vectors are more efficient when compared to linked list in some things, but linked list is also pretty efficient in some things. Both have trade-offs, but vectors are the ones that are mostly used, but a linked list is fairly easy to implement itself, to implement. So we can basically first start with implementing a linked list to get the idea of how a dynamic array works. Then we can just move on to vectors here. I'll be lying if I say that implementing a vector is difficult. It's really not. But at first, we just like to focus on what a linked list is, how it works. Then we can just simply move on to vectors. Then we have workings and types of linked lists. Linked lists are of two types. Firstly, we have a singly linked list, and then we have a doubly linked list. Again, these will be discussed in depth in the future. Then we have shortcoming of linked lists and need for vectors, and then just working of vectors and memory leaks. We'll discuss a little bit of memory leaks in this topic too. What is memory in C, call stack, and heap? Because memory leaks are a pretty big problem, and anyone who is working in any type of low-level language that involves manual memory management If you're working with Rust, manual memory management is not something you have to do. Rust takes care of the memory by itself without even having a borrow checker. But if you're working in C or C++, manual memory management is the only tool you have. And as you might know, if you're doing something manually, there are big chances of just, messing up. So, uh, memory leaks can happen because C and C++ require manual memory management. Memory leaks basically mean that memory is being allocated even though there's no need for it. And we'll again discuss that thing in the future. So this is the basic outline of the course. And one of the first topics that we are going to discuss is the need for dynamic arrays and memory in C. Now, memory in C is usually something we'd be discussing even we uh, after we talk about something like variables, constants, conditional statements like if else, loops like a for loop, a while loop, or a do while loop. So memories in C is basically usually something that is discussed after these topics. But again, I prefer discussing it first because again, my ideology on this is simply that run first, trip over, then maybe try to walk. Now this guy's running, and this guy's just, learning how to walk. So it's pretty simple. This is the ideology this whole course is based upon, and that's why I'll be touching on a bit more, not complex or advanced, just a bit more intermediate level topics first, then go on to easier topics like these three here. So that's all for the intro, and thank you for watching. Bye bye.